My name is Mohammed and today I will show you a small demo for Modbus integration, and also I will show you how to integrate this with our BMS for remote analysis. Whether you are an engineer or a technician or just curious about BMS system, this video is beneficial for all the persons. So let's dive into it. So before integrating or before showing the demo, I will show you some theoretical part. So let's come closer. Come here. So first, if you are integrating any Modbus device, so in this video I will show you a energy meter, digital energy meter. So if you want to integrate any Modbus device, what you have to do? First, you need some things about the Modbus device. First of all, you need a proper documentation for the Modbus devices. What type of documentation you need? First of all, you need the register addresses. Okay, what is register? So in Modbus protocol, every parameter or every details or every points are stored in somewhere in the storage. So we call it register. So each parameter, like for voltage, for currents, for the loads and everything, they are stored in somewhere in the locations of the memory, and we call that location as a register. So first of all, if you are integrating any Modbus device, first of all you need register addresses for each parameter. Come, I will show you here. So for my case, I am integrating RIS LM 360 digital energy meter. As you can see over here, this is the meter. So for this, I downloaded some of the documentation from internet. So what you need? Mainly you need this register addressing, as you can see here. For voltage 1, V1 stand for the voltage across the red wire. Okay, this is from neutral, line to neutral. Okay, line to neutral voltage. As you can see, it's stored in 3001 location, 30001 location in 3x address. Okay, and also it's stored in 4001 addresses, as you can see over here. Okay, the addresses which start from 3, it's called as you can see over here, the addresses which start from 3, it's called as input register. Okay, and the addresses which start from 4x, it's called as holding register. Holding registers are the registers in which we can manipulate the value. Okay, we can manipulate the value also and we can read the value also. But for the 3x location, we can only read the inputs. Okay, we are not able to manipulate the value. So as you can see, for voltage 2 means the Y phase voltage, it is stored in 3003. Okay, as you can see, from 1 to 3, there is missing 2 is missing over here, because they mentioned here 2 consecutive 16-bit register represent one parameter. Means 2-bit register, it requires to store the parameter, store the value. Means this voltage V1 it is stored in 3001 and 3002. Means 2 register. So that's why 2 is not mentioned here. From 1 to 2 for one parameter, from 3 and 4 for second parameter, from 5 and 6 for third parameter. So these 1, 2, 3 for the voltages, 1, 2, 3 for the currents, and this is for the wattage. So first of all, if you want to integrate any Modbus device, you have to download this documentation in which they mention their register addresses for their parameters. And the second thing, I will show you here. You have to take care about this thing. Communication parameter. Okay, communication parameter. In which what is the main thing? Main thing is addresses setting. Okay, means in Modbus, each device has a unique address from which we have to set on the device itself. So as you can see over here, the devices, the allowable range for addresses is from 1 to 247. Okay, between 1 to 247 we can allow any addresses to any of the device. And the second thing is baud rate. Okay, baud rate for this device, what I am going to show you, the baud rate is 4800, 9600 up to 57,600 kilo baud rate. Okay, so you can choose any baud rate. Baud rate means what? The baud rate means the speed of the data transmission. Okay, you can set any of the baud rate, but please take care. If you set 9600 baud rate, So all the devices on that network must be same baud rate. If the baud rate is different, your device will not be communicated to the BMS. The second thing is a parity. So there is a lots of options. Fourth option is there. Four option. If you want to set the parity or not. If no, okay. What is the stop bit? So there is four options. No parity with one stop bit. No parity with two stop bit. Even parity with one stop bit and odd parity with one stop bit. So you can set any of the parity as per your requirement. Okay. So mainly you have to set the group addresses, unique addresses for each Modbus device first, and the second thing, the baud rate for a network must be same for all the devices connected to that same network. And very importantly, you must have the documentation for the register addressing for each parameter. So as I show you, so let's move to the field side. I will show you. In our electrical room, we have installed a 5 to 6 meter in our electrical room. So we will show you the practical demo there. So let's move to electrical room side. Okay, just pause the video. Pause, sir. So as you can see, now we are in our electrical room. Okay, so I will show you each meter. As you can see over here, this is the meter installed in the panel EDP1. Okay, this is an emergency panel. So we'll install the meter over here. So I will show you from inside. As you can see over here, there is some wire. So these three wire for the three phases R, Y, and B, and the fourth one is a neutral. Okay, the two are the power supply for this meter. Okay, so it's taking the power supply. Auxiliary power supply is from 100 volt to 550 volt AC or DC. You can provide for the meter. And below, as you can see here, there is two pair of red wire, two pair of green, and yellow and two pair of blue wire is here. This is for CT wire. Okay, once you install the CT, you have to connect the wire over here. And these two wire are for the RS485 communication for Modbus. So this is the wiring connection for this meter, and I will show you some of the configuration for this meter. So I will show you how we can set the addresses over here. Okay, as you can see, this is the communication selection communication parameter. Once I went to it, what is showing? Addresses, device addresses 31. For this meter, we have set the addresses as 31. This address must be unique for your entire network. Okay, if the two addresses are same, the device will not longer be communicating. Okay, so this addresses must be unique for all the devices. Okay, now as you can see here, the baud rate is 57.6. Okay, kilo. Means the baud rate is 57,600. Okay, the speed of the data. Okay, transfer speed of the data. The next is parity. Whatever I've used, no parity with one stop bit. Okay, and quit. So I'll already show you the addresses for this meter. Okay, I will show you another meter over here. As you can see, 2 meters is downside and 1 meter is upside. So as you can see, the baud rate for all the meters must be 57.6 kilo. Okay, if the baud rate is different, it will not longer be communicated. But the addresses for each of the meter must be different, must be unique. For this device, I will show you what is the addresses for this device. So let me go to the configuration. As you can see, the addresses is 30. Okay, the address is 30 for this meter, and the baud rate 57.6. Okay, for this meter also you can see the address is different, but the baud rate must be same for all the devices. As you can see, the address is 32 for this meter, and baud rate is same 57.6. Okay, so let me show you. All this meter, 1, 2, 3, 4, and one over there. One over there. All these 5 meters. All these 5 meters are connected in one network in a DC chain structure. Means from the wire coming from there, the RS485 communication wire is coming from there. It's coming to this meter, then to this meter, then to this, then to this, and after this, it's connecting to one of our router over there. This router is Modbus to TCP gateway. Okay, this is the gateway. I will show you. As you can see, this router, I will show you. This router is from Teltonica, okay, company, and the router model is RUT955. Okay, what it's doing? What is doing? This it's a gateway in which we are connecting our over there. This green connector. We are connecting our Modbus cable over here and the Ethernet port from here. Means we can connect our Ethernet from here, Ethernet port, Ethernet cable here to connect to our PC. So I will show you I already show you all the things, means the meters and the router also. Now I will show you the configuration, how to configure this with our system. So for that, what I have taken, I have bring another Cat6 cable. So I will connect this router to my PC. So I will show you how we can integrate the points in my system. So let me connect this cable there. I have connected one end of the cable to the router and the another end I will connect to my PC. Okay. Is it visible?
Yes.
So let me show you. So first what I will do, as you know, the addresses for these devices, are from 30, 31, 32. Okay. So what I will do, I will first read the values from software, free of cost software from CAS Modbus Scanner. I will read from here. So to read from here, what you have to do? First, we have to know the IP address for the router. Okay. If you configure the router first time, you must have to know the IP. Okay. When you are configure, you know the IP and the port and the subnet mask and the gateway. Okay. So what I will do? I know the IP for this router. The IP for this router is 192.168.94.2.18. Okay. So what I will do here, I will click add connection to the CAS Modbus Scanner, and it will ask whether you want to connect through a serial connection or the TCP connection. So in this video, I will connect through the TCP connection as I have used a gateway over here. But in the upcoming videos, I will also show you how we can connect through a serial connection. Okay. So what you have to do, just type the IP over here. IP address 192.168.94, okay, 0.94.18. Okay, this is our IP. The port is 502, okay, by default. Okay, the port is correct. So I will click add TCP connection. Once I click over here, you can see the TCP device is connected over here. Now I want to read the data. Suppose I want to read for this device. Okay. I want to read the data for this device. What is the amperes? What is the voltages? Okay, line to line voltage, line to meter voltage. What is the kilowatt for this? So what I will do? First, I will show you the addresses for this. What is the address for this device? So as you can see, the address is 31. Okay. So remember the address for this device is 31, and so you can see the ampere. I will show you the ampere over here. The ampere is 31. 43 and 29 for RYB, 3 phases. Okay, the address is 31. So what I will do, in the IP, I will right click. So it's showing the add connection or add device. So I will add the devices. So it's asking what is the addresses, what is the slave ID. So the slave ID is 31. So I added the device here over here. 31 device 31. Now what I want to do from this 31, I want to read something. So add task. What I want to do, I want to read the addresses for the register, value for the register. That is nothing but holding register. Okay, because I show you in the documentation time, the each value, each parameter are stored in the 4x and 3x register, both register. So I'm reading 4x also. If you want, you can read 3x also if they stored on 3x also. And is asking the offset and also the length. So I'm reading for 30 only. I want to read up to 40001 to 4000330. Okay, 400330. So at the request, once you double click on the device, once you double click over here, it's gonna poll. Okay, from here you can just poll. Once you poll, it will read from there. Okay, wait for a minute. Let me check what happened over here, because it's not reading. Maybe the IP address is I need to change my IP also for my system. So I will check what is my IP. My IP is 192. Okay, I will change my IP. I think the problem is from IP side. So I will change my IP to 192.168.94.114. Okay. Okay, I change my IP to, now the IP is 192.168.94.18 for the gateway itself, and the my IP is 114. Okay, once I polled, see, it's reading the value. What the value is reading over here, I will show you the value. For the first register, as you can see, it's showing 222 point something. Okay, means this is the voltage in R phase. Okay, this is the voltage for Y phase, and this is the voltage for B phase. Okay, apart from voltage, it's showing the current also. The current for the R phase is 30 point something. Okay, for Y phase it's showing 43, and for B phase it's 29. Means 30, 43 and 29. We will say from the current was showing over there is 30, here 31 point something. Okay, because why there is some difference, because I read that just now. Maybe I need to read again, so it will update it there. And the current is 43 and 29. 31, 43, 29. So let's check here. 30, 43 and 29. So these two are showing correct, 43 and 29, but the field size 30. So I will poll it again. Once I poll it again, it's showing please wait. Once it polled, it will show you 30.28. This is the voltage, and this is the current for R, Y and B phase, and the others are the different things. Okay, so as you can see, how can we read from the separate from the software, free of cost software. But now I will show you how we can integrate this value to one of our system from NetX automation. The system, the BMS software is NetX BMS Platform. As you can see, the software is here. Okay, in this software I will show you, there is a icon as Modbus. Just click on the Modbus. It will ask you the device definitions. As you can see, already I have added 3 devices. So what I am gonna do now, I will make these 3 devices as disable. I disable these 3 devices, and I'm gonna add a new devices. Okay, so add a new definition. It's asking the name of the device. Okay, what is the name of the device? Name of the device, as you can see over there in the field side, I'm gonna read the value for this device. So what is the name I have to give to this device? It's totally dependent upon us, totally dependent upon the integration. Okay, so what I will do, I will name that this device at the name of the panel. The panel name is EDP1. So the device name I will make as EDP1. I can make any name, but it's better to make the device's name as the panel name, so you will get the idea. Okay, this panel is reading for this device is reading for this panel. So what I will do, I will write the device name as EDP1. Okay, so EDP1. Okay, device name, as you can see over there, it's asking device name. Okay, next the IP addresses. Okay, it's asking the IP address. What is the IP addresses? I already tell you, 192.168.94.18. 18 is the IP for this device, and the port number by default is 502. What is the slave ID? Slave ID is 31, and here you can write some descriptions if you want. Suppose emergency panel basement 1. Okay, this is the panel located in basement 1. So I can write any description as per our need. So just save. And now when you click on the Modbus, there is another tab known as data point definition. So as you can see over here also, I have added some of the data points before. So what I'm going to do now, I will make all as a comment. So I will add the new data points. I will add a new from here. So it's asking first device name. The device name what you have added before must be same. If not, you will not get any value from there. So what I'm doing, the first device name we have put as a EDP1. So on the data points itself, I will make the device name as EDP1. Okay. And the Modbus data type. What is the type of the data? So the data type is holding register or input register. You can read any value. Okay. So I'll select as the input register. Now it's asking the addresses. For the addresses here, you have to start from 0. Okay. I will tell you why we are starting from 0. Also it's asking the data points. What is the data point? The data point is 32-bit and float value is there. So 32-bit float. And for the rest, it's optional. But for the 0, what we are getting the voltage. Okay, VOLTAGE. Voltage for what? Line to neutral voltage. Okay. Now I can make copy of this and just paste. So it's easy to change only. Okay, the second one is same, but the address is different. The address I have to write as 2, and this is the voltage from line to neutral. This is for R phase. Okay, R. This is the same line to neutral but for Y phase, and another one. The address is 4, but the value what we are getting from there is for B phase. So I have included only 3 points for voltages in R phase, Y phase and B phase. So just save, and once you save, just restart the server. Once you restart, I will show you. It will take some time because I have restarted the system. Okay. So what you have to do, you have to go to item tree and the XIO branch. In the XIO branch, you will find the branches what you have linked. Like here, it's showing KNX and Modbus. Okay, if you integrated backnet also, it will show the backnet also, SNMP also. Okay, lots of protocol we can include in this system. So in this case, we will move to Modbus branch. As you can see over here, it's showing the EDP1. So once I am integrating the Modbus device, I have wrote the name what I want. So at that time, we write the name as a EDP1 because the panel name is EDP1. Once you click on EDP1, it will show you some branches. Okay, each branches is for each type of register. Okay, these two are for the discrete inputs and coils are for the digital values, and the rest of the tools are for analog value. So in this case, we have included an input register. Okay, I will show you here also. When I am integrating these 3 points, 1, 2, 3 points, what I have done here, I have selected as an input register in all the 3 cases. So I have to move to input registers. Once you open, it will show you the value. Okay, see the voltage line to neutral for R phase, voltage line to neutral for Y phase, and voltage line to neutral for B phase. So in R phase, it's showing 222 point something. For the B phase, we have to read the value. So once you read, it will show you the value for that also. And for the B phase, it's showing the value. Okay. So now what I will do, I will read some current value from there. What you have to do to read the current value, just copy the same thing. Okay. No need to write again and again. Just copy the same thing. Okay. Just change the addresses. As I know, because I have read all the documentation for this. So for the current in R phase, what you have to do, we have to read as 6. Okay, for R phase. And name, what is this? This is the current for the R phase. So let's write as R amps. Okay, R phase amperes. Okay, so this will give us the current in R phase. Okay, same thing if you want to read for Y phase, you have to go for address 8, and if you want to read for the B phase, you have to go for addresses 10. So, and the rest of the thing are same. So I will just copy and paste, so you will get the data from here. So all the things are same, are input register. Okay, just go to input register, and the float value, all are float value 32 bits. Okay, so just go 32 bits from here also, and from here also you have to go 32 bits, and name. This is the rest of the two are for the amperes, but in different phases. The second one is for Y phase, okay, and the last one is for B phase. Okay, once you write all the points, whatever point you need from the documentation, just read what you want. Like if you want to the voltages, currents, the energy consumptions, power factor, whatever you want, just take the values from there and implement over here. Just make that the addresses must be correct. If you write the wrong addresses, it will not gonna work. So once you write all the things, just save all and restart the server. Once you click on yes, it will restart the server again. So see, now the system is going to be shut down, and after shutdown it will again restart. So once you restart, what we will see 3 more values for the currents in the BMS. So let me show you. It will take some time to start, maybe for 15 to 20 seconds. So now it's fully restart. Now I will show you. Okay, so once you go on item tree, okay, item tree, go to XIO branch and then Modbus, and your panel name is there. In the panel name, go to input register. So now what you will do, you can see here it's showing 3 more values, is R, Y and B. Okay, so for the R, if you want to check the currents, how much current is consuming, just read the R value. You are seeing that 33 amperes it's showing, and the field side also you can see over here. The amperes is 33. Okay, the field side the ampere is also 33. For Y phase 43 and for B phase 27. So we'll read Y also and B also. Okay, so for Y phase it must show, Y phase is showing 42 point something. Okay, and that side is 43.8 and that side is 43. So and for B we'll read the value. For B it's showing 27. Okay, exactly same. So now what is the issue with the program? When I'm restarting my server, it's not going to read automatically. So what I will do, I will enable, once we restart our server, it must read from itself. We don't need to read it manually. So what you have to do, just go to your data points, and there you will find a column that is showing read on reconnect. So what you have to do, just enable this point as a true. Okay, so for this read on reconnect, just make it true. I will show you how. Just make it true. Once you make it true, what it will do, it will automatically, once you restart the server, you don't need to read the value again and again. After a 5,000 milliseconds of polling interval, it will automatically gonna read the value. You don't need to read it again. So it will automatically read the value for you. So just I'll make true for all the points. Let me see. Okay, once you make it true, you have to restart the server again, so that whatever changes you made on your program, it will again save the changes and it will again restart. Once this restart, now you will see that I don't need to read the values from myself. The BMS automatically it's pull the meters and it will read the value from the meter itself. Okay, so let the system to be restart again. So now as you can see over in the XIO branch, in the Modbus, in the EDP panel, and just go to input registers. So still it's not showing. Maybe it will take some time. So just wait for the reading. Also, as you can see over here, it's all are true. So it must read automatically from there. So it will take some time to read, and whatever it reads, you can see from here also, group Telegram monitor, whatever value it reads from there, it will show, it will reflect to here. So in this video, I'll show you how we can integrate a Modbus device. Okay, any Modbus device for my case, I have used a meter that is belongs to RIS LM, okay, 360, 1360, the model number. But in your case, any of the device which supports Modbus protocol, you can integrate to the BMS also, and also you can read from a free software that is from the CAS. So you can read from there also and from the BMS also. In the upcoming videos, I will show you another meter which is from Jiggler, and I will read the value for the Jiggler meter, not from the router itself, because in this case I have used router TCP connection to read the values from the meter. But in the next video, for the Jiggler meter, I will read from the serial port. The serial port means from one side we will connect our Modbus cable, the another side there is a USB which I will connect to my PC directly. Okay, on the serial port communication we don't require any gateway for the conversion of Modbus to TCP IP. So hope you like the video. So thank you for your support. Have fun. Goodbye.